Hey guys! Today we're going to look at writing ionic formulas without actually having to draw them first. So the drawing helps a lot when it comes to picturing these bonds and why they happen, how they happen. But the fact of the matter is, I'm lazy, and I like to do less work, and drawing them actually adds a couple extra steps. So first we need to review what oxidation numbers are. Oxidation number is the charge that an element wants to have. So what charge will they have once they become stable? Sodium is in the first column. He has a single valence electron, so when he kicks them out, he will have a charge of +1. Oxygen is in the 16th column. He has 6 valence electrons. Once he fills the extra spaces, he wants to have a charge of -2. So sodium kicks 1 electron out, which means he has more protons than electrons, +1 charge. Oxygen gains 2 extra electrons, so he has a -2 charge. So here's a periodic table to help us see that. The first column, 1 valence electron, they will have a +1 charge. The second column, 2 valence electrons, they will have a +2 charge. Transition metals we're going to talk about a little bit later. The 13th column has 3 valence electrons, they will have a +3 charge. The 14th column has 4 valence electrons. Now these could have a charge of a positive or a negative value. It's still going to be a value of 4, but it's going to be +4 if it's a metal, like down here, and it's going to be -4 if it's a nonmetal or a metalloid. Column 15 has 5 valence, so now they want to gain 3 extra electrons, which gives them a -3 charge. Column 16 is a -2 charge, column 17 is a -1 charge. So think how many electrons do they want to kick out, or how many electrons do they want to gain, and that gives you their oxidation number. So here are the steps for writing the chemical formula. Write the symbol of the element that has the positive oxidation number with the oxidation number as a superscript. That's an up top number. If it is a transition metal, the number that is written in parentheses when they write the name is the oxidation number. Then write the symbol of the element that has a negative oxidation number, and write the oxidation number as the superscript up top. Crisscross the numbers down, remove the pluses or the minuses, and simplify out. So for example, that's sodium and oxygen. Sodium is Na with a +1. Oxygen has a -2 charge once it is stable. I'm going to take this 1 and crisscross it down. I'm going to take this 2 and crisscross it down. And essentially what this does is help us balance the charges. A sodium with a +1 and an oxygen with a -2. We want the overall charge to be 0. So in order for that to happen, I need 2 sodiums and only 1 oxygen. So when you crisscross, you circle criss, circle cross. Notice I took away the pluses and the minuses, and I simplified out. I don't have to write a 1 for oxygen. So we're going to do it 2 more times. Aluminum sulfide is Al. Al has a +3 charge. Sulfur is S with a -2 charge. I'm going to take this, and I'm going to criss. Take this, and I'm going to cross. And I'm going to rewrite it, Al2S3. Okay, so we need 2 aluminums with a +3 charge and 3 sulfurs with a -2 charge to zero out those charge values. Now manganese 3 fluoride. This is what I was talking about when I said Roman numerals. Manganese is actually Mn, and since there is a 3 value in this Roman numeral, the oxidation number for manganese is +3. Fluorine is F, and the oxidation number is -1. So circle criss, circle cross, and rewrite manganese, I only need 1, but fluorine, I need 3 to have a stable ionic bond. Now I am going to ask you to go the other way around. I might give you a chemical formula, and I'm going to expect you to name what that ionic formula is. So in order to do this, you have a couple steps. Reverse crisscross your subscripts to determine your oxidation numbers. check your nonmetal. Is that oxidation number the number that it's supposed to be? If it's not, you have to adjust it. Write the name of the cation, which stays the same. Write the oxidation number of the cation in parentheses, and then write the name of the anion with the suffix of IDE. So just like ionic bonds, this is exactly the same except for that second middle step. Write the oxidation number of the cation in parentheses. Since transition metals can have anywhere from 2 to 4 valence electrons, we do need to indicate exactly how many are present. Alright, so we're going to do a few examples. Step number 1 is take the numbers that you are given and reverse crisscross them back up. So when we do that, we have Ti with a +1, because there was no number out here, and we have N with a -3. Step 2 is check your oxidation numbers. Nitrogen has 5 valence electrons, so he wants to have a charge of -3 to fill in those last 3 spots. So we checked, and that oxidation number is correct. So we're going to rewrite the name, titanium, 1 in parentheses, because our oxidation number here is 1, and we have to signify it, and nitrogen turns into nitride, just like normal. So the second example, step 1 is reverse your crisscross. This number goes up here, this number goes back up here. So we have Mn with a +1 charge, since there was no number, and O with a -1 charge, -1 charge. Now we have to check our work. What charge does oxygen want to have? He actually wants to have a charge of 2. So that tells us that at some point we simplified our subscripts. So we're going to multiply this by 2 to get it back to the number that we want it to be. But if we multiply oxygen by 2, we also have to multiply manganese by 2. So we have Mn +2, O -2. At this point, our oxidation numbers are correct. So we have manganese 2 oxide as our name. Now this last one, reverse your numbers back up to the top, and we have zinc with a +2 and bromine with a -1. Bromine has 7 valence electrons, so he wants to have a charge of -1, so we don't have to adjust this section at all. We just have to rewrite our name, zinc 2 bromide. So when we're doing that funny middle section of the periodic table, the transition metal section, all of your names must have a Roman numeral in parentheses to indicate the number of valence electrons for that element. So now that we've practiced this and I've kind of showed you how to do the shortcut, I do want to see how you can do this on your own in class. I'll be there to help and I'll be there to answer questions, but remember, we're trying to save some time by skipping drawings, so that way we can go straight to writing the names and the formulas. Okay, so I'll see you tomorrow so we can practice.